We have question number 20 from Miscellaneous Exercise chapter number 4. It's something so interesting. It gives you a general quadratic equation ax square plus bx plus c with a condition that it has real roots. If it has real roots, that means its discriminant should be bigger than or equal to 0. That means b square minus 4ac should be bigger than or equal to 0. Now this is something that we need to remember for the other parts of the question, that b square minus 4ac has a positive or a non-negative value. Lock that in your mind. We move to part A. In part A they are asking us that show that if you take an other general equation but its coefficients are different, it is cx squared minus bx plus a equal to 0. So the first and third coefficients have been swapped, changed. It also has real roots. We have to show that. So we take the discriminant again, but we are not setting discriminant to bigger than or equal to 0. We need to deduce that it will be bigger than or equal to 0 eventually. So I say that okay, let's take discriminant, but now we are representing it with different coefficients or constants. So we choose capital B square minus 4ac to represent the discriminant of this equation. Okay, where this capital A will be equal to c because the leading coefficient here is c. So capital A is c, B is minus b, and capital C is equal to a. We put all these values in the discriminant. We will have b square, that is minus b square minus 4ca. If we multiply them, the square of negative b will be b square minus 4ac, and we already know the value of b square minus 4ac, that it is non-negative. That means this part is again a non-negative, and this part is the discriminant of the new equation. If the discriminant of the new equation is non-negative, that means the new equation also has real roots. We are done with that. We move to part B. It says that if you take yet another equation which has the leading coefficient to be a, very similar as we had in the first one, but the second coefficient is mb instead of just b. Here we had b. In the new equation we have mb as the second coefficient, and we have m square c as the constant term. So our capital A is a, our capital B is mb, and the capital C is m square c. We are again going for the discriminant b square minus 4ac. So we put the value of b and a and c. We reduce the discriminant. So we have m square b square minus 4 times a times c times m square. If I factor out m square, I am left with b square minus 4ac in the bracket. So I have two factors. The product of m square and b square minus 4ac gives me the new discriminant, right? If you look at it, we already know that b square minus 4ac is non-negative. So b square minus 4ac is non-negative. That's one thing that we know. Second, m has a square. Anything that has a square can never be negative, right? Any real number, if you square a real number, it can either be 0 if the number is 0, or it can be positive. So m square is bigger than or equal to 0. B square minus 4ac is bigger than or equal to 0. We already know that from the given information. So if you multiply a non-negative number with a non-negative number, the product is again non-negative. This product was my new discriminant. If the new discriminant is non-negative, that means the equation has real roots. Look at question number 22. It says that show that the line y equals to 5x minus 4 is tangent to the curve y equals to x square plus x. So if a line is tangent to the curve, all that we need to show is that their discriminant, when we are solving the equation, their discriminant should be equal to 0, right? So we take y equals to 5x minus 4, that's our line, and y equals to x square plus x, that's the curve. If they are tangential to each other, that means they meet at a point, that means they will be equal at one point at least. So we set them equal to each other. We simplify the equation. We have x square minus 4x plus 4 equal to 0. So the leading coefficient is 1, the other coefficient is minus 4, constant is 4. we need to find the value of d, but we are not setting d to anything. We are not putting it equal to or not equal to something. We are just finding the value of d, and if that value becomes 0, we have made our point, right? So we find the value of discriminant. We put values, that's minus 4 squared minus 4 times 1 times 4, that becomes 16 minus 16, which is equal to 0. Discriminant became 0. That's what we needed to prove. It means the line and curve are tangential to each other. We made our point. Now they are asking us about another thing. They are saying also give the condition for which every line, if you take every linear equation that you take, such as y equals to mx minus c, if there's any line generally, if you take that line and you want that line to be tangential to the same curve x square plus x, what should be the condition on m and c? So what should be the relation between m and c? We equate the curve x square plus x with that general line mx minus c. We merge the equation, so we have x square plus 1 minus m times x plus c. So my leading coefficient is 1, the second coefficient is 1 minus m, and the constant is c. I put it in discriminant, but now I know that discriminant should be set to 0 because the condition is already given, that what should be the condition in order for them to be tangential to each other. So if I put the values in the discriminant and set it equal to 0, I have 1 minus m square equal to 4c. That means c should be equal to 1 minus m square divided by 4. Whenever c and m are in this relation with each other, that line would always be tangential to the curve x square plus x. In question number 23, they have given us some conditions. They say a quadratic curve is symmetric about x equals to 3. If a curve is symmetric about any x value, that means that's the x value or location for its maximum value, right? So we know that every quadratic curve is always symmetric about its h value, right? So if x is equals to 3 is the line of symmetry, that means the value of h is 3. Now we are not sure if that curve would be concave upward or downward, so we made a rough sketch of both curves. It would look like this, having an axis of symmetry at 3 if it is concave upward, otherwise it would look like this. Then the next condition that they have given is that the curve passes through these 2 points, 2 comma 13 and negative 1 comma negative 2. If we just look at the structure that they have presented, you see if you are increasing values from negative 1 to 2, you are increasing the x values, you are getting an increment in the y values as well. That means before reaching the maximum point, because the maximum point is at 3, right? So we have not reached at 3 yet, the graph is increasing. So it's increasing before the maximum point. That means it should look like this in the end when we have the graph, but we don't know what would be the exact shape of the graph right now. The question is asking us to find the equation of the curve and then sketch it. So we assume the standard form of the quadratic function or equation as y equals to a times x minus h whole square plus k. We already have an idea of h, that h is equals to 3, so we put h to be 3. Now we need to find the values of a and k. That's 2 unknowns, and we already know 2 conditions, that when x is 2, y is 13, and when x is negative 1, y is negative 2. We use these 2 conditions. We put y equal to 13 and x is equals to 2 and resolve it, so we get 13 is equals to a plus k, or k is equals to 13 minus a. From the second part, we put y equals to minus 2 and x equals to minus 1, so negative 1 and negative 3 becomes negative 4, the square of which is 16. 16 times a plus k becomes minus 2. If I replace k with this value, that is 13 minus a, I will have 16a minus a, which is 15a. Bringing 13 to this side, I will have negative 2 minus 13, which is negative 15. So 15 times a is negative 15, that means a is negative 1. If a is negative 1, that means I will have a concave downward graph, right? Perfect. We put a to be minus 1 here, and I get the value of k to be 14. Now I put all of the values in the equation. So the equation was a times x plus minus h whole squared plus k. That becomes minus 1 times x minus 3 whole square plus 14. That means my vertex or the maximum value is 3 comma 14. So if I try to draw the graph, I will draw the maximum point at 3 comma 14. If I look at the y-intercept, I need to put x equal to 0. So you put x equal to 0, you have negative 3 squared, which is 9 multiplied with minus 1. So that's minus 9 plus 14. So that becomes 5. So you have y-intercept at 5. You have vertex at 3 comma 14. That gives you a rough sketch of the graph. That's what it was needed. Well, question number 24 of miscellaneous 4 asks that what value of m will make this entire expression 2m minus 1 x squared minus 4 times m minus 2 times x plus m minus 1 a perfect square. Now we need to know that what's a condition for the perfect square. If you take any perfect square such as x plus m whole square, if I expand it, I have x square plus 2mx plus m square. The leading coefficient is 1, b is 2m and c is m squared. If I find the discriminant of it, I see that the discriminant b square minus 4ac becomes 0. That means x plus m whole square, if I draw it, it will be tangential to x-axis at location x equals to minus m. We observe the same behavior in x square. So x square can be written as x plus 0 or x minus 0 whole squared. It's a perfect square and it only touches x-axis at one location, which is 0. If I take x minus 1 whole square, that will touch x-axis only once at x is equals to plus 1. So you take any perfect square and it will be tangential to x-axis. That means it will have repeated real roots, right? So in that case, the discriminant should be equal to 0. So in order to make this one a perfect square, we need to set the discriminant equal to 0. We take the leading coefficient to be 2m minus 1, b is equals to minus 4 times m minus 2 and c is equals to m minus 1. We put these values in the discriminant and set that equal to 0. We simplify everything and we get 2m square minus 13m plus 15 equal to 0. We split the middle term, we get two factors and the values, the possible values for m are either m is equals to 5 or it should be equal to 3 by 2.